Okay, so previously we've looked at transformations which act on the x, things like f of x plus 2 or f of 2x. And we saw that those basically looked like we were solving equations, so we did the opposite of what it said. If it said x plus 2, we subtracted 2 from all of the x values. If it said 2x, we halved all of the x values due to the idea of solving equations. Now we've got the graph of y equals f of x again. Again, it's not important what the function of x is, we just know what it looks like and we're going to transform its graph. So this is a graph y equals fx. We want to draw y equals f of x, but now we're going to, after we've done the function, then add 2. So let's just think about what that's going to look like. It's basically saying that at this stage it does exactly the same function. So at this stage here, it's just got exactly the same function, and then we add 2. So in fact, everything is going to be lined up exactly as it was with the x values. The only thing that changes is that the y values have then increased by 2. So if we sketch on this graph, it's going to look almost identical. The only difference will be that it has shifted up by 2. As we said previously, the x values are unaffected. That asymptote is still at x equals minus 2. This turning point still has an x coordinate of 2, but its y coordinate has been moved up by 2. The same values of the function, and then we add 2 to them. This asymptote will also move, and it will move up to 5. Again, we can do that with no knowledge of what the function is. We just know how that transformation will affect the graph. Okay, so let's have a look at a slightly different transformation again. I'll just erase all of that. We'll draw the same graph back on. I think it looks something like that. I think it was 2, 5. Now, however, we're going to try and sketch the graph of 3 f of x. So again, we think it through with the same logical process. F of x, exactly the same as it was before, still has all the same values for the same x's, but then we triple the result. So what that means is everything's going to look almost the same, except it will be stretched out by a factor of 3, parallel to the y-axis. So notice where the y value was 0, 0 times 3 is still 0. They intersect at exactly the same point. Down here, where it was negative, it becomes 3 times as negative. It's stretched. Up here, that turning point, the x value will still be at 2, but it will have moved up to 15, 3 times greater. This asymptote here will be at y equals 9. Again, same kind of thing, but everything, if it's a y value, has been made 3 times greater.